Good morning, Great Lakes Academy scholars. Mr. Manta here, and I would like to welcome you to our video lesson for today. Today being Tuesday, April 14th, I believe, where we are jumping into the second lesson within our new unit number 6, all about chemistry. This is going to be lesson 2, learning about particles in chemistry. We'll get to just what that means in a second. If you haven't watched our first lesson for this new unit from yesterday, then go do that lesson first and then come on back to this one, or otherwise things aren't really going to make sense. We're going to start today off, in fact, with a do now, reviewing the stuff that we learned on yesterday's lesson. For your do now, go ahead and in your science notebook create a heading that looks kind of like this, with spaces for questions 1, 2, and 3. And here are those questions right here. You don't need to write the questions out, just give me the answers in your notebook to these 3 questions, 1, 2, and 3. Pause the video and answer the questions with pencil and paper now. Alright, I'm going to assume that we have now finished writing out our answers. I'm going to bring it back and show you the answers for these 3 questions. First off, we were asking, what is the definition of matter? We learned yesterday, matter is anything that has weight and takes up space. It has to do both of those things to be considered matter. So a brick is matter. Water is matter. Lava is matter. The laptop that I'm looking at right now is matter. I am matter. You are matter. Some examples of things that aren't matter are light waves or thoughts or dreams, things that don't have weight or don't take up space. Second of all, what are the 3 states of matter that we learned about yesterday? We learned that matter can be a solid, a liquid, or a gas. Those are the 3 states of matter that we're going to be talking about throughout this unit. Some of you guys might have some extra knowledge, and you might say, Mr. Manta, there's a 4th state of matter called plasma, and that's true. We're just not covering plasma really, at least in this science unit. We're going to stick to just these 3, solids, liquids, and gases. If you want to learn more about plasma on your own time, heck, write up a science bite. That'd be awesome. I'd give you some extra credit for it. Third question was true or false, air has weight. That, in fact, is true. We know that's true because in yesterday's crash course video, we watched a demonstration where they hung a meter stick from a string, they put a balloon on each end, and then they added air to one of the balloons to blow it up. And that balloon swung down lower, it hung lower on the meter stick than the other one, showing that the air they added to the balloon has weight. So those 3 answers are these 3 answers that we're looking at right here. For today's first classwork question, you're actually just going to go on the classwork form and tell me which questions did you get right and wrong on today's do now. Explain also, please, why you got a wrong answer for any questions that you missed. So just to make this really clear, because a couple folks are still getting confused on the classwork questions, if I come to today's classwork assignment and I click on the form and I look at it here, I have classwork question 1, and you are going to answer this question I'm asking you. So the question is, which questions did you get right or wrong in today's do now? So your answer might sound something like, I got numbers 1 and 2 right, but I missed number 3. And then explain why. I thought that air floated, so it didn't, something like that, you know. So you're answering your questions in classwork question 1 and classwork question 2. All right, pause the video and take care of that now if you haven't already done so. And I'm going to assume that you've now done that, and we are moving on from there. All right, to recap what we learned yesterday, just a little bit more thoroughly on top of our do now, this is our new unit on chemistry that we're doing. And yes, we will eventually talk about chemical reactions. But first, we're going to learn about the chemistry of everyday objects. And I mean everyday objects, like the stuff that might be around you right now, all this stuff. The reason why is because we need to talk about this stuff before we can kind of have a general sense of what's going on when we look at a chemical reaction. We learned yesterday that all of this stuff around us is matter because, 1, it has weight, and 2, it takes up space. And those are the 2 things that something needs to have to be considered a kind of matter. Today's questions, though, that we're going to learn about in this new lesson for today is, what really is matter? Like what would you see if you could zoom in super close? Like, what is matter really made of? I want you to imagine maybe that you had like the most giant, powerful, incredible microscope of all time, and you could zoom in super close on any kind of object, and you took just like a regular everyday object, like a pencil or something, and you put it under your microscope, and then you looked through at it. What would you see? What really is matter when you look super duper closely at it? That's what we're going to find out today. Today's big question, the way we're phrasing it, is what is matter made of? To answer that question, we're going to go to our friends at Crash Course. Listen up, she's going to go quickly. I'll recap the main takeaways from the video, but pay very close attention to what our friend Sabrina has to say.
You ever hear someone say you look like $1,000,000? Well, you do. But you also look like 1,000,000 particles. Let me explain. You and I are both made of matter. I don't mean we matter like we're important, even though of course we are. I mean we actually are matter. Matter, as you know, is anything that has weight and takes up space, and we did a whole video about it. But what is matter made of? It's made of particles. So you, as a big thing of matter, are made of particles. The device you're watching this on is made of particles. Your dog is made of particles. You get the idea. Particles are so tiny though, you can't see them. Just picture them as super small balls packed together to form an object. And how an object looks and behaves, which we call its properties, has a lot to do with those tiny particles that it's made of. Let's take a look. You know that most matter comes in 3 states: solid, liquid, or gas. Particles in a solid are packed so tight that they don't move, and they keep you from moving through it, like a brick wall. Now, don't try running through a brick wall, just trust me on this. But in a liquid, there's more space between the particles. That extra room between them allows them to slide around. That's why you can stick an object into or through a liquid, like dropping a straw in a glass of soda or wading through a pool of water. And there is so much space between the constantly moving particles in a gas that you can move around in them easily. In fact, when you walk from one side of the room to the other, you've walked through a bunch of gases that make up air. But if something is a solid, will it always stay a solid? Is a liquid always a liquid? Do gases ever become non-gases? To find out if matter can change states, let's find examples of when objects' properties change. Then we can figure out what's happening to their particles. Here's one, a candle. It's solid, right? Made of wax? But when you light the candle, the packed particles loosen up and the wax begins to melt. Liquid wax. So a solid can become a liquid. Now here's another. Let's say you've got a pot of water on the stove. If you heat a liquid up, its particles will move around so fast that they can't hold on to each other. When that happens, all of the particles fly apart and become a gas, like the steam you see when you boil water. So a liquid can become a gas. Okay, one more. How about a forest on a really cold night? Or even on your front lawn. When it's cold enough, water vapor, a gas in the air, turns into tiny crystals of frost, which you see on trees or grass. The free-floating particles in the gas join together and form a solid around the plants, so a gas can become a solid. But my favorite example of a state of change? The Wizard of Oz, definitely. Remember when the Wicked Witch of the West melts at the end? She totally goes from a solid to a liquid. Okay, but seriously, what does all of this mean? An object made of matter can change its properties when it changes states. And remember, it doesn't make a difference which state of matter an object is in, solid, liquid, or gas. It's still always matter. To sum up, matter is everywhere. Matter is made of particles, therefore particles are everywhere. So, like I always say, never trust a particle. They make up everything.
Alright, y'all. You know, I make some bad jokes in class sometimes, but I hope you at least think that my jokes aren't quite that bad as that last one. I want to run through really quickly the main stuff that we just learned from that Crash Course video. We're going to have 3 key points from this, and yes, every single one of these you should write down in your science notebook. First of all, the first thing that she talked about is that all matter is made up of particles that are so small you can't see them, or at least not without a microscope. Now, I want to be very clear on this because there's a thing that I think a few students might be confused about that I want to be really clear about. I want you to think for a second about a sandcastle, maybe one that you made on a beach sometime that looks kind of like this. When Mr. Manta tells you that all matter is made out of particles, you might be thinking, oh, okay, I get it. So like the sandcastle, right? It's made of little particles of sand. And maybe if I had a magnifying lens and I could look really closely at the sandcastle, I would see that it's made up of these little grains of sand. So, Mr. Manta, those are the particles that you're thinking of, right? Well, no. yes, a sandcastle is made up of grains of sand, but the particles that we're talking about that make up matter are even way, way smaller than grains of sand. In fact, to see the kinds of particles that really make up matter, you would have to take a different kind of microscope, or like an electron microscope, which is way more powerful than a magnifying lens, and look at the grains of sand themselves and keep zooming in and zooming in and zooming in. And eventually, you would be able to see that they're made up of these tiny, incredibly small microscopic particles. We're going to be learning what those are later on, atoms and molecules, but for now, just know that they are these tiny, tiny little bits of things that make up everything. Second thing I want to point out that they talked about in the video is that whether something is a solid, liquid, or gas depends on what's going on with its particles. Now, she ran through kind of quickly what the particles are doing in each of those different states. This animation can definitely help, I think, though, too. So we see the three different states of matter being represented in this animation. What it shows us is that a gas, when you have anything that's in the form of a gas, its particles are kind of freely flying around and just kind of bouncing into each other once in a while. They expand as a group and they kind of take up whatever space they have available to them. And so they can have a large volume or a small volume, depending if you put them in a large container or a small container. And they're bouncing all over the place. If you have an object that is instead a liquid, the particles in a liquid, they have a definite volume. Like they stay all kind of condensed together, but they can freely kind of slide around and among each other. So all these different little water particles or water molecules are flowing and sliding through each other. And you could put your finger right in a glass of water and move it around, and you can stir all the molecules around. Lastly, if you have an object that's in the state of matter we call solid, that means its particles are like locked together, like holding each other together in the same spot. They're maybe like shaking and vibrating a little bit, but they are actually, in a way, kind of bound together. So it's going to keep its shape. Like this thing is staying in this kind of cube-like shape. It's not melting and flowing out into the rest of the jar. It stays with its shape, and you can't move through it very quickly. You can't move your finger through something that's solid the way that you can move it through a liquid or a gas. In order to even further demonstrate what I'm talking about, I have a simulation to show you. Let's go to that now. So if I come over here, this is a simulation that I'm talking about. So in this simulation, we're going to see three different states of matter for water. So we have solid water, which is ice cubes. We're going to have liquid water, and we're going to have water vapor, which is a gas, inside of this cup. The first thing I want to point out is that for each of these different states, the thing that makes water be solid instead of liquid instead of gas is the temperature that you're going to see up here. So for example, first of all, I have solid water ice cubes. That's because it's at -1 degree Celsius, which is like 30 degrees Fahrenheit or so. It's below freezing. It's below the freezing point where water becomes ice. If it's liquid, then that means it's like a normal temperature, maybe something like 21 degrees Celsius, which is like about the temperature it is outside on a nice day, and you can have liquid water in a cup. And to have gaseous water, though, it needs to be really hot, over 101 degrees Celsius, or I believe it's 212 degrees Fahrenheit. So the temperature is what affects the state of matter here. Now when I press play, the simulation is going to pour the cup out into the little trough that we have here, and we're going to see what happens. If we pour the solid ice cubes out into the trough, they kind of bounce around and they fill the trough, but they each stay their same shape. Each one of these here is still a cube. And these little red dots that you can see inside of them are representing the water particles that are all holding each other together, and they're all bound to each other, so it's like a rigid, solid structure. Kind of like maybe if you ever made a giant cube of Legos or something like that. They're all stuck together. If we turn our water into a liquid by raising the temperature, and now we have this liquid water where all the molecules are kind of freely flowing around each other and all mixed in together like a crowd. When we pour that cup out, all of the water molecules come spilling out into this trough. They are still kind of freely flowing around each other, but they've changed, the overall glass of water has changed its shape now, right? Now it's kind of filling up that rectangular shape instead of being in this cup shape that we have right here. So when you have a liquid, it can change its shape from being shaped like a cup to now it's shaped like a rectangle because it's in the rectangular container. Lastly, if we have a gas, what you're noticing here is that the particles are bouncing around like crazy and bouncing off of each other. And in fact, they would be flying outside of the cup if we didn't have a lid on top of this cup right now. We're going to try to pour the cup of water into the trough, but we'll see how well that actually goes for us. When you take the lid off of this cup, the molecule, or the particles, I'm sorry, just kind of go flying everywhere. You can't really pour out water vapor, because when water is in the state of matter of being a gas, the particles kind of fly everywhere and fill up as much space as they have, whether that's in this tiny little cup or in the whole room in general. So that was another way that you can visualize what the particles are doing when particles are in a solid versus a liquid versus a gas. I hope that helps. Getting back to our presentation here. The third point that they also made in that crash course, actually before we go on to the third point, we have a classwork question. So pause the video and go ahead and answer this in the classwork form. The question is, what's the difference between the particles in a solid and the particles in a liquid? You have to put this in your own words. You should be answering that question, giving me your answer right here where it says classwork question 2. Whatever your answer might be, right there. Pause the video if you haven't already done so and do that now. Alright, I'm bringing us back now, assuming that you've gone and answered that question. I'm going to move on from there and talk about the third key point that they made in the crash course video, which is that matter can change from one state to another depending on its temperature. So, when we talk about water, we are well aware now that water can be a solid, a liquid, or a gas. What's important to know here, what this point is saying, is that that depends on the temperature of the water. When you make water really cold, it freezes into solid ice. When water is like a normal temperature, room temperature, you usually have liquid water. And if you boil it, if you make it really hot, it turns into a gas. And each of those states of matter, it changes what's going on with the particles, if you could zoom in and see really closely. Whether they're all locked together, holding each other in place, or kind of flowing around each other, or just bouncing all over the place like crazy. So for example, if you took some really cold liquid water and you put an ice cube in it like this guy does, and you made it a little bit colder, you can freeze it into solid ice. So right there, what you're seeing is that all these particles that are currently a liquid are instead changing and becoming a little bit colder and becoming ice. The opposite, though, is also true. So if you have a whole bunch of water that's really hot and you heat it up even more in a pot by cooking with gas, by setting a fire underneath it, that water is getting so hot that it's boiling, that all this liquid water is turning into gas and bubbling up to the top. So you can use temperature to change any kind of matter's state of matter to make it a solid, a liquid, or a gas. Alright, that's all the new material that we have for today. So before we go, we're going to have an independent practice. Pause the video for just a second and write out these numbers 1 through 10 somewhere in your notebook so you can write down your answers. Do that first. And moving right along, our 10 independent practice questions for today are right here. Pause the video and answer each of these 10 questions. You don't have to write the whole question, just the answer, in your notebook now. Alright, I'm bringing it back, assuming that you have now completed that, so I can go ahead and show the answers. You're going to be starring the answers that you got correct and crossing out and fixing the ones that you got wrong. Here we are. Number 1, the three states of matter are solid, liquid, and gas, at least the ones we're talking about in this class. Number 2, matter is anything that has weight and takes up space. Number 3, since you are matter, you are made up of tiny particles, because everything that's matter is made up of particles. Number 4, true or false, matter can change from one state to another. That is true. We just saw a whole bunch of examples of that. Number 5, the state of matter that something is in depends on what's going on with its particles. So the particles are doing something very different when something is solid versus liquid versus gas. Number 6, when the particles of matter are locked together in a definite shape, it is a solid. That's what it means for something to be solid. Number 7, matter can change from one state to another depending on its temperature. Number 8, when the particles in matter can slide around freely among each other, it's a liquid. Number 9, true or false, you can see the particles that make up matter if you just have a magnifying glass. That's false. You need a super crazy powerful microscope like an electron microscope to do that. And number 10, when the particles in matter can fly around all over the place, it is a gas. That is our third state of matter that we were learning about. So go ahead and cross out or star all of your answers that you got, fix ones that you got wrong, and please, then your last part of your classwork questions are to go into the classwork form and check off all the questions that you got correct. So Mr. Manton knows which ones we're doing good with and which ones people could use more practice on. Alright, ladies and gentlemen, that is all that we had for today. It is now exit ticket time. Yes, there is an exit ticket for today. Yes, everybody has to do it. No, there is no independent reading. What I also want to point out, today's cool thing, of course, is a YouTube channel that I'm a huge fan of. I might have mentioned it somewhere in class before, called Minute Earth. They got like 2 million subscribers or something. They're super interesting. They do these really fascinating videos that are like kind of, you learn something always, but they're definitely not like school, or sometimes they're science related for sure. One really cool one that I watched recently, they went through all the various fictional dragons in like Pokemon and Lord of the Rings and How to Train Your Dragon in different movies, and they tried to figure out scientifically which one of those would be the most realistic to actually have if you had a real dragon in the real world. And unfortunately for my friend Charizard over here, it didn't fare very well for him. So check out Minute Earth on YouTube just if you're bored sometime. Alright, knock out your last classroom questions and the exit ticket, and I will see you folks tomorrow. Take care.